Hello, and welcome to Becca Breaks It Down. In this episode, we are going to look at something called the law of sines. The law of sines can be used to determine unknown side lengths and angle measures of oblique triangles. If you're wondering what an oblique triangle is, well, it's not a right triangle. Okay. So the law of sines states that the ratio of the sine of an angle to the length of its opposite side is the same for all three angles of any triangle. So this right here, sine of angle A divided by side A, that's the ratio of the sine of angle A to the length of its opposite side, which is side A. Okay, so notice in our diagram that we are identifying our sides using the same letters as our angles, but opposite angle A is side A, and opposite angle B is side B, and opposite angle C is side C. Now, the law of sines only works when you have the buddy system. And so, like angle A and side A, that angle and its opposite side is the buddy system. So I can totally use law of sines if I know angle A and side A, or if I know angle B and side B, or if I know angle C and side C. But I need to have that buddy system in order to use the law of sines. Now I can use the law of sines to find missing side lengths. I can also use them to find missing angle measures. Remember, when you go to calculate a missing angle measure, you should use an inverse trig function. And that's when I usually say, wait a second, I don't know the angle measure, because to get that inverse trig function on your screen, you need to use that second button on your calculator. Okay, so let's take a look at a problem. And before we do that, speaking of the calculator, check your mode right now. Make sure that your calculator is in degree mode. All right, so here in problem one, I want to find BC. So I'm going to start by labeling my sides A, B, and C. So opposite angle A is side A, opposite angle B is side B, and opposite angle C is side C. Now, if I want to find BC, BC is being represented by side A. So I'm definitely going to be using this ratio, sine of angle A over side A. What is the measure of angle A? Yeah, so they don't flat out give us the measure of angle A, but please, I hope you realize you can easily find it because you know angle B is 88.5 and you know that angle C is 50.5, sorry about that. So if you just subtract from 180, you'll get the measure of angle A. So 180 minus those two, we get that angle A is 41 degrees. Okay, so now I can write out this ratio. So I can be like sine angle A, which is 41 degrees, divided by side A. Now, I'm only going to work with two of these ratios at a time. I'm not going to work with all three. So what is the second ratio that I'm going to use? This is where I look for that buddy system. So right here, I have an angle side pair. I know angle B and I know side B. So it makes perfect sense that my second ratio that I'm going to use would be sine of angle B over side B. So this is what it looks like starting off. Okay, so this is my initial equation using the law of sines. Okay, I've got my buddy system ratio. I've got the ratio that I'm using to find side A. To solve this is a proportion, so you can cross multiply. All right, so let's take a look at what all of this looks like because I've already done the work. Okay, so what I did is I cross multiplied. So I went A times sine of 88.5. Okay, and I went 35 times sine of 41. So these were my cross products that I'm showing you right here. Right? I have to get a by itself, so I have to divide both sides by sine of 88. And so when I'm all ready to calculate, what I'm typing into my calculator is 35 times sine of 41 divided by sine of 88. Now I would do this in 2 steps. Like I would first calculate 35 sine of 41, get that answer on your calculator, then divide that answer by sine of 88, just to be on the safe side. So I would try it, and do you get 22.97? Okay, because that is the measure of side BC. So here we used the law of sines to find a missing side length. So now let's use the law of sines to find a missing angle measure. So at problem number 2, I want to find the measure of angle A, right? So I'm definitely going to be using that angle A side A ratio, okay? And then it's like, well, what other ratio do I know? So I'm looking for that buddy system, and I see that buddy system right here with angle B and side B. So I'm going to be using these 2 ratios to write my initial law of sines equation. So I'm going to have sine of angle A divided by side A, which is 14. And this is going to be equal to sine of angle B. Angle B is 59 degrees divided by side B, which is 16.1. So this is where I start using my law of sines. This is my initial equation. From here, I simply want to cross multiply and go about solving in that manner. All right, so that is exactly what I did. Okay, so I found my cross products. I'm like sine of A times 16.1. And then I'm like 14 times sine of 59. I had to get sine of angle A by itself, so notice that I divided both sides by 16.1. And so this is where I'm at. Sine of angle A is equal to 14 times sine of 59 divided by 16.1. So I did that math. I calculated this, and I got a decimal equivalent of 0.7454. Then it's like, wait a second, I don't know the angle measure. So I realized I needed to calculate the inverse sine of that decimal. And so I got 48.2 degrees as my angle measure. So this is how we can use law of sines to find a missing side or a missing angle in a triangle. Law of sines, you need to know the buddy system, so you need to know like angle A and side A, or angle B and side B, or angle C or side C. So as long as you have the buddy system in place, the law of sines can be used to find a missing measurement. And that's how Becker breaks it down.